Okay, so here we are in section 5.5. We're going to be going through questions 25 to 30. So starting at 25 through 28, we're just going to be trying to factor out as much as we can, coming up with the binomials and monomials that will come with it. So we look at 25. The first thing we should always do is see what we can factor out at the beginning. So it looks like there's a 2 and a pi in common with each of these terms. So let's just take that out by dividing pi by each of them. And then when we do that, what we're left with inside is going to be r squared minus, and then that will be 1 because pi divided by pi will just equal 1. If we look here, this is actually a special binomial. The r squared can be split into r and r, and the 1 can be split into 1, 1. So perfect squared binomial. So how we do this is we can just go ahead and put r and 1, leave a space in between inside some parentheses. And then you just need a plus and minus sign in between there. So when we do that back out, it will come back to be r squared minus 1. And then we just put 2 pi out front, and there is your answer for 25. Okay, going on to 26. Again, let's see what we can factor out first. So let's factor out a 3x, because that seems to be in common with both of them. When we do that, we get on the outside. On the inside, we're going to be left with 3, and then just x plus 1, because 3x divided by 3x will be 1. This is nothing special about this. There's nothing else we can do to make that less of a binomial or make it into 2 binomials. So that's the final answer. It's going to be 3x and then 3x plus 1. Okay, coming over to 27, we're going to go ahead and factor out 4. That looks like that's the thing that's in common here. When we do that, we're going to be left with b squared plus 64. And you can do that in your calculator, 256 divided by 4. And since there is a plus sign in here, we can't go any further with this. Only if it was a minus would it be a special binomial, but because it's not, it's a plus sign or addition sign, we're going to leave it as such, and our final answer is just going to be 4b squared plus 64. Okay, going on to the next one. If we look here, it looks like that every one of these terms has 6 in common. So we're going to pull out a 6 to begin with, and we're left with 3x to the third plus, for some weird reason I'm forgetting what that is, 9, here we go, 9x squared plus x plus 3. Okay, and since there's 4 terms here, what we can actually do is just group these together. So we can just split these apart and see what pulls out of this first one. Out of the first parentheses here, we have 3, which goes to 9 as well, and x. So we can pull out a 3x squared from both of these. Remember that the 6 is just kind of here, but when we pull out 3x squared, we are going to get on the inside x, because the x squared will cancel all the x's, and you'll cancel out the 3's, and then it will be plus 3. The x squared will cancel out here. And then over here, we don't have to pull out anything, so we can just say plus 1, and then x plus 3. Okay, so now what we can do is we can take out x plus 3 from both of them. So we could divide that out since it's multiplied. And when we do that, we are left with 6x plus 3, and then whatever's left inside, which is going to be 3x squared plus 1. Okay, and it looks like that is the final answer for this one as well, because there's nothing else that we could do with those binomials or terms in there. Okay, going on to the word problems now. A billboard along the side of I-15 has an area represented by the polynomial 9y8 minus 100. Find 2 binomials that represent the length and width of the billboard. Recall that area is length times width. Okay, so pretty much what this means is that we have to find what is multiplied out to become this. So we have to factor. So there's nothing that we can factor out first. y to the 8th can be multiplied 3y to the 4th, 3y to the 4th. You multiply those together, it'll be 9y to the 8th. So it's perfect square. And this last one is also a perfect square because we have 10 and 10. And since it's a minus sign in the middle, we can go with perfect square binomials. So our final answer here would be 3y to the 4th minus 10 and 3y to the 4th plus 10. This is one of those methods that need to be memorized. It'll make your life a lot easier. Okay. And then that's the final answer for that. So one of these will be the length, one of these will be the width. It doesn't matter. They will be the same. Okay, so then coming down to the last one here, 30. A telephone booth with a square bottom has a volume of 175x to the third plus 140x squared plus 28x. Its height is represented by monomial and its length and width by binomial. So find a monomial and binomials that would represent these three dimensions. So usually the volume is represented by height times length times width. So we're going to be finding three different monomial and two binomials. So just looking at what we're dealing with here, it looks like that we can actually pull out a 7x from all of those. So if we divide 7x by each one of those, our first one we're going to come up with, divide that by 7. So our first one is going to be 25x squared because we're pulling out an x. And then our next one is 20x. Then our last one here is going to be plus 4. Yep. And there we go. So we have our monomial. Our monomial is just going to be the 7x there. But now we need to figure out how to factor this a little bit further. If we look at it, we actually have a perfect square here. It could be 5x and 5x. And then we actually have a perfect square back here as well. We have 2. Because if we multiply these together, we get 10x, and then if we multiply that by 2, we get 20x. So what that means is that this is a perfect square trinomial. So how we're going to write this is it's going to be 5x plus 2, because there's a plus sign here, it's positive 20, and then another 5x plus 2. This works because when we multiply it out, the middles will be added. So those 10x's there and here will be added together to become 20x when we multiply those together. And then the beginnings and ends are matched up as well. So that would be our two binomials that we're looking for. So really, we could say our height is the 7x. We could say our length is the 5x plus 2, and our width is 5x plus 2 as well. And that would be our final answer there.